to 500 years is how long it takes for plastic to decompose. And even if we do recycle 50% of plastic, well, even if we do collect 15% of the plastic to recycle, only 9% of it is actually recycled. So don't trust people. And if this continues, by 2050, there will be more plastic in the ocean than fish. Now, there you see, it's a problem. And to combat this, I found out about bioplastic when I was researching about the SDGs. Bioplastic connects with SDG 11 and SDG 12. SDG 14. And bioplastic is biodegradable. So if we use nature to make it, we give it back to nature. So I may have made this clear already, but just what do you think is bioplastic? The judges can, answer the question.
Should I try? So
Yeah.
it's plastic that's produced using organisms instead of chemistry.
That's basically it, right. So bioplastic is an alternative to plastic, judging by the name, and it's made using biomass, so which you said, organisms. But organisms are a part of biomass. There's also many more parts of biomass. So what are the advantages of bioplastic? First of all, bioplastic is recyclable and compostable. It can be molded and made into any shape you like. It's made from renewable materials. It's non-toxic, and it less money for managing the plastic waste. So plastic waste, managing between 2021 and 2040, could reach up to USD 670 billion. So let's talk about the history of bioplastic. In 1855, the first ever man-made bioplastic was made. It was made from cellulose, so it's technically considered as bioplastic. In 1975, Japanese scientists discovered a bacteria that was able to break down nylon. And in 2050, bioplastics are expected to grow to 46% of the market if we start making action now. So let's talk about my experiment, the main point of me being here. The aim of this experiment is to make 3 bioplastics: chitosan, gelatin, and cornstarch. Next, the question. I have 2 questions because the first question is too easy. Is bioplastic a renewable resource compared to plastic? My answer to that question, or also known as the hypothesis, is yes, because it's biomass, it's degradable. The second question is which bioplastic will I think will degrade the fastest? I think the chitosan will degrade the fastest, and that's because chitosan is a combination of protein and carbohydrates, and carbohydrates actually degrade faster than protein. And chitosan has the power of protein and carbohydrates, which logically makes sense for it to degrade fastest. And the method on how I did this is I produced 3 bioplastics and tested decomposing capability by keeping them in soluble decomposers and see which decomposes faster. So first, making the different bioplastics. For this, I need a saucepan, mold, scale, and a stirring utensil and parchment paper. So first, making the starch-based bioplastic. So I add 1 cup of water into the saucepan, and then I add 2 tablespoons of cornstarch. The cornstarch and water was really big to mix because it just mixed instantly. And starch-based bioplastic comes from corn, and its main component is carbohydrates. And that's the chemical formula of cornstarch down below. So I add 1 tablespoon of vinegar and 1 tablespoon of glycerol. Next, I mix it together in the saucepan and I heat the mixture. Now, for this, it's very liquidy. But once you heat the mixture, it turns into a thick mixture. And then I poured it into the mold. Pretty straightforward. Next is the gelatin-based bioplastic. Gelatin actually is a compound in jelly, and it comes from pigs. And that's why jelly is banned in some countries. And its main component is catechol and / protein. Protein is just the base, I think, of catechol, and that is chemical formula over there of gelatin. So I add gelatin, I 1 tablespoon of gelatin powder mixed with 2 tablespoons of water, 1 tablespoon of vinegar, and 1 tablespoon of glycerol, and then I mix it together. Now, the gelatin with water was harder to mix than the cornstarch because it also mixes. First, it turned immediately liquidy, and then it turned into a little bit thicker mixture. I then poured it into the mold and let it set. Next is the Chitosan bioplastic. Chitosan bioplastic, for this, I have 5 grams of chitosan. Chitosan is a compound extracted from shrimps, and as I told, it's made of oligosaccharides, and I think it's also called carbohydrates and protein, and that's the chemical formula of chitosan over there. So I had 5 grams of protein, 100 milliliters of water, 50 milliliters of vinegar, and 30 milliliters of glycerol. I then mixed it, poured it into the saucepan, and heat the mixture. And simple process, I poured it into the mold. So next is the biodegrading process. For this, I need my bioplastic that I just made and the scale. So this just ensures a fair test. All the bioplastics are around 13 to 14 grams. So this is cornstarch, it's 14 grams. This is gelatin, and the next is chitosan. I'm just showing you what all the grams are. Next is keeping the bioplastic in the soil. For this, I kept it in individual pots so I could observe the decomposing process over the weeks without any hurry-burry to find out where the bioplastics are in the soil. And now is the record of the measuring and observing part and monitoring part of the bioplastic in the coming weeks. So, yeah. So before we go into evaluating the decomposing process, we have to understand the decomposing process. So bioplastic undergoes biological breakdown, which makes it naturally decompose into blocks. This is affected by temperature, humidity, and sunlight. Then those blocks will undergo biological reaction, which degrade them into polymer chains, which will then further degrade them into molecular compounds. Then those molecular compounds will be intaked into microorganisms, and this is only the border of homogenization. The big part is when those microorganisms release gases such as CO2 and liquids such as H2O and CH4, which will then be intaked into plants. And this is the results. In week 1, all the bioplastics started at roughly the same mass, 14 grams. And I also had plastic as just a control variable, and that was just 5 grams. Stayed the same throughout the weeks. So in week 2, you can see that there's a major spike. That's because in the prime of the biological reaction, I've read that microorganisms go inside the bioplastic to decompose it. So my logical theory is that during this, chitosan has the most amount of microorganisms in it, making it faster to degrade. And then you can see that in week 6, chitosan is already biodegraded. In theory, this is because the high spike in week 2. And in week 11, cornstarch has biodegraded, and this may seem absurd because it has a low spike in week 2, but that was because gelatin was affected by other factors, such as the surrounding of soil when it was kept in weeks, which is why you can see by the time in week 6, gelatin is starting to slow down. In conclusion, the chitosan bioplastic and the cornstarch bioplastics have biodegraded, as you can see in week 11, and the chitosan bioplastic is the fastest degrade in my experiment. I am not claiming that chitosan bioplastic is the fastest. Gelatin bioplastic, I approximate, will take around 6 months to decompose because I've read that it's the longest time a bioplastic will decompose. But I'll have to check that after 6 months. Now, I referred to another experiment here just to check if my data was the same, and it was roughly the same. The reason it was higher was because I checked, and this experiment has less mass than to the mass that I used, which is 14 grams. And the next step is to check if the bioplastic can be mixed together, and if it can be mixed together, it will be better than the current ones, which is the non-mixed ones. Thank you for listening. Before I start with the questions, I just want to point this out to you. So these are all bioplastic sound that so this is a chosen bioplastic, just to show you. So this is the chosen bioplastic that I made. So that's why I wrapped in the cover so it doesn't break. And then this is all the different bioplastics that are also coming out to you. This is the cornstarch bioplastics. And you can see that it does act very much like a plastic cover. And also, this is the gelatin bioplastic. You can hold on. You can hold on to that. You can also hold on to this. Please don't open it.
So, Vibhu-san, very good. If there was a way to extend this study to expand on what you did already, have you thought about that? Is there something that you think might also be helpful in sort of expanding your understanding and knowledge about this?
Understanding knowledge about this would be to understand the more compounds on what oligosaccharides mean, and more about the materials that are used. Understanding the materials that are used in the bioplastic, so I can see which makes them degrade faster. Because I did say it was about protein and carbohydrates, but that could also be implemented by another factor that I have not realized and talked to yet. Making this experiment go further, it would be my next step to see if the bioplastics can be mixed together and can it be better than like the current ones, like the non-mixed ones. So that's my final answer.
Okay, thank you. Anybody else have some questions on the panel? Colin?
Which one tastes the best?
I would say, judging by the smell, cornstarch, because it has zero smell for me.
When I was a kid, I mean, when you gave these to us, this reminds me of a candy that we had when I was little. And so I think that you could make candy, and I think you could give it out to your classmates.
I could be able to make candy, but I would be able to make candy wrappers.
I mean, we would eat the candy burgers, so you might want to try that out. A serious question. So you've taken 11 to 14 weeks of data for each of the decays.
11 weeks. 11 weeks.
Suppose you wanted to describe that as a mathematical curve rather than just a bunch of points that were connected by straight lines.
Yeah,
What curve would you use?
I haven't studied about curves that much actually, because I haven't studied that. And as for a curve, I don't think Excel is able to do that. So
Okay.
I would have to try and represent it.
Okay, excellent. Thank you.
If you really want to do it well, talk with Andrew who did the statistics and you guys get together and it's really perfect. Go ahead, Mike.
Yeah, very interesting. So biodegradability is a very important attribute of bioplastics. But in order to have utility in the market, what other attributes do you think bioplastics need? Or in other words, you okay?
So when you say utility, do you mean what does it need to withstand the market?
Exactly. What can be done with these things? How useful are they?
So
Fake
I've just
plastics, right?
So I've handed you out like samples of the plastic, and you've probably tested, and it works as well as plastics.
In a bag, a plastic bag.
In a plastic bag, I've actually tried it out. It withstands some force, but the problem is plastics are more flexible than bioplastics, and to withstand the market, plastic is also extremely cheap. It's cheaper than a lot of stuff in the markets. So that would mean people will have to make it bioplastics cheap, which is hard because then you would have to export a lot of stuff, which will then cause more pollution. So that is still a resolving issue.
Anybody else? Okay, thank you very much, Vibhu.